Final year project panels look for evidence of real-world, enterprise-grade AI skills. To stand out, your submission must handle the same architectural challenges found in professional engineering environments. Today, we are going to build exactly that. We will construct a generative AI-powered virtual assistant using IBM Watsonx. We will pull raw, scattered data and fuse it into a single architecture. The GitHub repository we are using starts as a nutrition agent, answering questions about meal plans and diets based on PDF data. But the real power of this codebase is modularity. Once you understand the setup, you can swap the nutrition data to fit finance, legal, or healthcare documents. Mastering this specific stack demonstrates the ability to design complex AI systems. This shift in perspective makes your portfolio highly competitive during placement season. The core of our application relies on IBM's Granite or Mistral large language models, accessed through Watsonx. These models act as our foundational intelligence engine, generating the human-like text our users read. Standard LLMs have a known flaw. If you ask them a highly specific question, they try to answer entirely from memory. This is like taking a closed-book test. They guess, and that leads to hallucinations, outputting completely fabricated information. This animated diagram shows how we fix this using Retrieval Augmented Generation, or RAG. Instead of that locked box of memory, RAG acts as an open reference book. It forces the AI to read specific, uploaded reference materials before it formulates a response. Implementing RAG entirely eliminates the risk of your final year project feeding false information to a user. The model only speaks when it has the source text to back it up. This introduces a mechanical problem. If you upload a massive multi-page PDF, how does the system instantly locate the exact sentence relevant to the user's question? The answer is Vectorized Document Search. We rely on a mathematical mechanism for finding relevance, rather than basic keyword matching. Watch this grid. Paragraphs translate into numerical vectors, becoming dots clustered on a 3D plane by meaning. A user's question drops in as a new dot. We measure physical distance between dots to determine semantic similarity. The closest dots provide the answer. Being able to articulate this vector math proves to an evaluation panel that you comprehend the deep engineering behind the search pipeline, not just how to call a top-level API. Next, we need to govern how the AI processes that retrieved data. For this, the repository uses LangGraph ReAct Architecture, which acts as the traffic controller for the AI's logic. ReAct stands for reason and act. In the reason phase, the agent pauses. It analyzes the complexity of the user's prompt to determine what information it actually needs, rather than answering blindly. This flowchart tracks the process. The agent triggers the act node, executing a vector search to pull context from the PDF. Then, the observe node reviews the retrieved data to ensure it answers the question, before moving to the reply path. The ReAct loop provides a framework for autonomous reasoning, adding a layer of technical depth that linear chatbots lack. Let's get the code. Open your terminal and run the git clone command on the nutrition agent repository linked in the description. Navigate into your newly downloaded project directory. Inside, you will find the main Jupyter Notebook file. Go ahead and launch it. Before you run any cells, you must install all the packages listed in the requirements file. Skipping this step guarantees broken builds and failed imports. Executing these setup steps systematically ensures you have a stable, error-free foundation for the customization phase. To make this project yours, we need to discard the default nutrition theme. Your submission needs to be entirely unique compared to your peers. Open the data folder. Delete the existing nutrition agent PDF and drag in a new domain-specific document, like a corporate tax code, a complex hardware manual, or hospital healthcare guidelines. Next, locate the system prompt inside the Jupyter Notebook code. As shown here, delete the nutrition agent line and rewrite it to match your new domain, like expert financial advisor. By pivoting the data source, you adapt an open-source framework into a specialized application tailored for a specific industry. When you start your Viva presentation, open with a live demo. Type in a highly specific question that only exists in your uploaded PDF. This proves to your panel that the AI relies on your custom data. Provide a specific justification for selecting IBM Watsonx. Tell them that enterprise-grade, trustworthy AI models are mandatory requirements in professional environments. Connecting the AI's function to real-world business ROI, like hospital triage or banking efficiency, demonstrates the commercial awareness that evaluators prioritize. You have successfully combined a large language model, a vectorized document search pipeline, and a customized knowledge base into a single application. These individual components lock together perfectly. You now have a robust system ready to deploy into the real world. Support the open-source development behind this by starring the GitHub repository. Subscribe to the channel for more architecture breakdowns and share your custom domains in the comments below. Welcome to the new AI engineering community.